Okay, so second video. All I'm going to do here is show you how to draw a piece, or show you how I've decided to draw a piece at least, and to put it on the grid at a particular place. I've had to import sine, cos, and pi from math. I've decided to specify a piece radius here. Again, the user should be able to tinker around with this as long as it goes up from 0.1 to 0.5 of the row height, which is equal to the column width, then it will be within the size of the column. If you made this too big, for instance, it would be too big to fit in a cell. Nothing else I don't think has changed there. Let's look at draw regular polygon. So I started off with draw circle. There is actually no way to draw a circle using GL just by specifying I'd like a circle, please. So this function, I've decided I need to specify the x and y of the center of the circle. R is the radius of the circle. N is the number of vertices that will be used to create the circle. Now that sounds a bit weird, but essentially what we're doing here is only drawing regular polygons. If I put an n equals 3, I'd get a triangle, and an n equals 4, I'd get a square, and so on. In fact, I'm using a default of something like n equals 64 here, which gives me a 64-sided polygon, which looks like a circle, and then I've got the default color here. Now, you saw earlier on when I draw a line, I have to give a set of vertices, and as long as it's got the right number, this is in fact a tuple, not a set, a tuple of vertices, as long as it's got the right number of vertices according to that number there, I'm not going to get an error. What I can do, in fact, is I can build up this list of vertices and then just pass it as a variable, which is what I do here. Let's have a quick look at this bit first. I'm going to draw n vertices here. We're in polygon mode, which means it's going to loop back from the last vertex to the first vertex and then fill the thing in. Each one of my vertices is two-dimensional, and it's a float in this case because I'm going to have to work it out using Pythagoras theorem. And again, we've got 4 bytes per color, and I just multiply color by n, so every vertex has its own color. In order to generate the vertices, I start off with an empty list, and is theta, which is going to be my angle in radians that I need to calculate where my vertices are going to be. I want to make the vertex centered on x and y, but I have to add a bit. If you imagine, let's quickly have a look at this here. I want to draw centered on this point, but I've got to add something to x to offset and draw a vertex here, vertex, 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 and I'm going to draw all those round, and then it will fill them in for me. So I calculate these by running up to n, which is 64, so 0 to 63 inclusive. I add to the list of vertices a list of x plus r sine theta and y plus r cos theta. I don't know if the grade 9s are going to be very interested in working through all that. Some of the honours mathematicians might. But essentially, you can imagine how that's going to draw as we sweep out theta, because we increase theta here by 2 pi over n. So we get 64 increments to theta as we go round in a circle. We're tracing the points on the circumference of the circle as we go around, and we add those to the vertices list, and then I pass vertices to the polygon, and it draws a circle for me if my n is sufficiently large. Just a quick note on what that thing is. That's actually a perfectly valid variable name in Python, and it's conventionally used as a loop counter to communicate the fact that we don't use it. We don't actually use that value at all. I could put something else there, but then you might look at this and think, well, why have you bothered to name that variable when you're not using it? Okay, so that's all that's about. That draws a polygon centered on x, y of radius r. And then I make it a little bit more connect4 friendly by calling it draw piece here. And draw piece takes an XY. This time the XY is different. This isn't a pixel coordinate. This is a coordinate on the connect4 grid. So 0, 0 is the bottom left square, and 6, 5 is the top right. So you can now draw pieces in this rather easier way using this function. All it does is we get to the right column, but then we've got to head to the middle of the column to center our polygon. So we have x times the column width to get to the right column, and then we add half the column to get to the middle of the column, and we have y times the row height to get to the right row, and then add half of the row height to get to the middle. So this would place us right bang in the center of a grid square. Piece radius I decided, I said earlier on, to make configurable here. So that's my R that I pass in. 64 here, I'll probably make that configurable as well. If people want to change their pieces to pentagons, they can put a 5 there. And the color is default. Again, I will make the color configurable up here so people can have different piece colors. So let's run that. Oh, so what do I do here? Let me just check. I call this now. I call the grid, and I draw a piece at 2, 3. That's all I do, and this is a red piece. So this is just testing code. I'm not going to do. I'm going to have to write another function to draw the entire representation of the board, but I haven't got to that yet. So let's just see how that runs. Okay, so that draws 0, 1, 2, 0, 1, 2, 3. This is 2, 3, and that's me passing 2, 3 there, and it's red. I won't go into showing you what, showing you the different coordinates work, and that changing 64 to a 3 turns it to a triangle. You can work through that yourself. I don't think there's anything else there. No, so that will do for that video.